Today in Capechi's Corner, we're going to look at graphing linear systems. Okay, so let's take a look at some vocabulary first. So first, what we're going to talk about is intersection. We're going to be graphing lines today. So the intersection is where the lines are going to meet. A system of linear equations, which is what we're going to be working on in the next few lessons, is when we have more than one line or equation. Now, the solution of the system of linear equations, once we graph it, that's going to be where the lines meet. So we are also going to call that the point of intersection. All right, so we have a couple different types of solutions of linear systems. So think about this. When I'm going to graph two lines, there's only a few different ways where they can meet. They can either meet one time, and that is when the slope is different, or the y-intercept can be the same or different. Doesn't matter. They could meet at the y-intercept or they can meet anywhere else. If there is no solution, that means that there is no way the lines are going to meet. And when does that happen? Well, that happens when they're parallel lines. The slope is the same, right? The slope or the rate of change or the angle is the same, but they're going to have different y-intercepts. And our last type of solution of a linear system is when they're infinite solutions. So what happens there, you can say, if I were to draw one line and then the other line was right on top of it, it would touch an infinite number of points. So when does that happen? When it's the exact same line, right? The slope is the same and the y-intercept is the same. Okay, so there's three ways that solutions can touch. They can either touch at one spot, where they have one solution, no solution when they're parallel lines, or an infinite solutions when it's one line right on top of each other. Okay, so let's get into some graphing the systems. So basically what we're going to do is we're going to graph both lines, and then we're going to find the intersection point, and then we're going to check it. All right, so here we go. Well, let's graph the first one. So my y-intercept is -4. Right? And my slope here is going to be -2. So that's -2/1. So I'm going to go down and to the right. So I go down 2 to the right 1. And since I'm running out of room, I'm going to go the other direction. I'm going to go up 2 to left 1, up 2 to left 1. I'm going to do lots of points because I really don't know where these lines are going to meet. Okay? So I'm going to graph my line. Here's my line there. And I'll do the same thing with the other one. See what we got. Okay, so what I did was for this equation here is I took that equation, I changed that 0.5 to 1/2. So my slope is going to be 1/2. So I'm going to go up 1 to the right 2. So I'm going to start at 6. Now again, if I were going to go up to the right, I'd be off the graph. So I'm going to do the opposite directions. Down 1 to the left 2, down 1 to the left 2. There's my point of intersection. I'm going to do one more, down 1 to left 2. I'm going to graph my line by connecting those points. Okay, now I'm going to look for my point of intersection, right, where the two lines meet, and they meet at -4, 4. Okay, so that's my point of intersection. It's the solution to the linear system. Okay, so now we're going to check it. The great thing about checking is on your homework or on a quiz, you can know for sure whether or not you got the right answer. So what I'm going to do is I'm going to write both of the original equations. I'm not going to worry about what I did when I changed anything or moved anything around. And I'm going to substitute, right? This is x and this is y. So I have +4 is equal to -2 times -4 minus 4. So it gives me 4 is equal to +8 minus 4, and that's true. So we know that that point is on that line. We're going to do the same thing with our other equations. So I have +4 is 0.5 times -4 plus 6. That gives me 4 is equal to -2 plus 6, and that's true. So again, now I know for sure that -4, +4 is my solution to the linear system, which is my point of intersection. Okay? All right, moving on. Let's take this equation right here. And again, first thing I want to make sure it's in slope-intercept form, so I just kind of switch the order a little bit. So when I go up 5, 1, 2, 3, 4, 5. And I'm going to go down 1, 2, 3 to the right 1, right? Down to the right. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. I'm going to do the same thing in the other direction. 1, 2, 3 to the left 1. And now I'm going to draw my line. Okay, I'll do the same thing. Now with this other line here, I rewrote it because I have to put that in slope-intercept form first, right? So I'm going to bring my 15x to the up. Still have it in my line mode. I'm going to bring that 15x to the other side. So I have 5y is equal to negative 15x plus 25. Divide everything by 5. And I have y is equal to negative 3x plus 5. Okay? Now, if you notice, that is the exact same equation I had up here, right? So if I were to graph that again, it would be right on top of each other. So I don't really need to do that. I just know they're right on top of each other. So how many solutions, right? What is the solution? In this case, we have infinite solutions. Because if we were to graph this one, it would just be right on top of it, right? It would be right on top of it. So those lines are going to touch an infinite number of points. All right, and looking at the next one, I brought down this one equation, and I put 4x to the other side, right? I have to get it in slope-intercept form. So I have y is equal to 2x plus 4. So I'm going to start at 4, 1, 2, 3, 4. I'm going to go up 2 to the right 1, up 2 to the right 1. I'll do the same thing in the other direction. And then I will draw my line. Make sure I put arrows on the end, right? Because the line's continuous. And then let's look at the other one here. So again, I have to add 2x to the other side to get it in slope-intercept form. Now, before I even graph this one, I noticed that my slope is the same and my y-intercept is different. So I do know that I'm going to have parallel lines, right? So I have 1, 2, 3, 4, 5, 6, up 2 to the right 1, up 2 to the right 1. And from there, again, I'll graph my line. Okay, and you notice that, again, we have parallel lines. So what is the solution there? We don't have a solution, right? So there's no solution because they don't touch at all. So you have to make sure you add that. You have no solutions. Those lines are not going to touch. All right, so let's get ready to graph another system. So my first equation's right here, right? So my slope, I just brought it down. My slope, I'm going to go up 5 to the right 2. So I'm going to start at negative 6. 1, 2, 3, 4, 5, 6. I'm going to go up 5 to the right 2, up 1, 2, 3, 4, 5 to the right 2, and then I'll draw my line. I like to put probably 3 or 4 points for sure, just because I don't really know where those lines are going to touch, right? So I want to make sure that I'm as accurate as possible. And I'm going to draw arrows on the end. I'm going to do same thing with my other equation, right? I have negative 2 to the right 1, so I'm going to go down to the right 1. So I'm going to start at 3. And I'm going to go down 2 to the right 1, down 2 to the right 1. There's my point of intersection, down 2 to the right 1. And I'll graph my line. Right, arrows in the end. So again, at this point, my point of intersection, we touched right here. So that is 2 on negative 1, right? That's my point of intersection. That's where both those lines meet. So again, we're going to do a quick check on this, just like we did earlier in the video, just to make sure my answers are right. So again, I'm always going to start with my original equation. So this is before I moved anything around. So I'm just going to rewrite that, and then we'll check it. So I have negative 1 is equal to 5 over 2 times 2 minus 6. So these will simplify. So I have 5 minus 6. That works. Same thing with my second one. See if I get a true statement. Oh, that's positive 2. So I have 8 times positive 2 plus 4 times negative 1. That equals 12. So that gives me 16 minus 4 equals 12. So I'm good. I know that my point of intersection that I have was correct. All right. let's take a look at our last one today. We're gonna do a little word problem and work with systems. Okay, Monisha and 5 of her friends. So we have Monisha and 5 of her friends. So we're talking about 6 people. That's going to be important. Want to attend a concert. They are trying to decide whether to buy tickets online in advance. So that's an option, or at the ticket booth on the day of the concert. They have $400 to buy the tickets. Okay, so for online, those tickets are $62 each. So 62 times X, so that's the number of tickets. And right there, Y is our total cost. And there's also a one-time $18 fee. Right? When we're looking at in person, there is no fee, but they're going to be slightly higher. They're going to charge us $67 per ticket. Okay. Now, which will cost less for all to attend? So there are 6 people total. So I'm going to substitute 16 in for X. That's the number of tickets. Use my calculator, and I get 390, and this is online. Okay, when I do in person, I'm going to do 67 again times 6, and that's going to give me 402. So which one will cost less? Online, we know here costs less. Okay, because we know that's 390 versus 402. All right, let's go from there. 2 of their friends realize they're not able to attend the concert. Is it better to buy tickets in advance? So again, we'll do the same thing. We'll use the same equation, and we're going to say online. This time, if 2 people can't attend, it's only going to be 4 people going, right? So we're going to do the same thing. We'll do the same thing for in person. This time, again, we're going to use the same equation, but we know we only have 4 people. You put both of these in your calculator. So online with 4 people is going to cost you $266. In person, it's going to cost you $268. Okay, so the question is it better to buy tickets in advance? And that's going to be a yes, because that one's cheaper. And then it says, what's the difference in the ticket for Part B? Well, it's $268 minus $266, so the difference is $2. Okay, thanks so much for stopping by today. You have a great day.